Good evening and welcome to another Electrical and Electronic Principles and Science with John. Today we're going to look at resistors. We're going to look at the resistor color codes, and then we're going to use an example to show how a resistor can be used in the circuit, and how Ohm's law applies to that circuit. Okay, here are a number of resistors. The components you actually see in electronic circuits, and obviously the circuits they're using will need some resistors in there to control the current in the circuit. And what you'll notice on these resistors are colour bands. Now some of them are different kinds. You've got carbon resistors and film resistors, but what's common to them all is that you can see these colours. Now what these colours do is denote the value of the resistor. So if we look at an example, the one I'm going to use in a very, very basic circuit, and what you can see on here is we've got a resistor. We're going to connect a supply in there, and we've got a position there where we can break the circuit. If you remember, when we wanted to measure current, we had to break the circuit to do it, and that's why I put this little flying lead in, and that'll become obvious in a moment. But first of all, let's concentrate on this component. You've got three colour bands, colour band 1, 2, 3, which is called the multiplier band, and that will tell you how many zeros to put on the end of it. So basically if we multiply in by 10, 100, 1000, 10,000, etc. And then you have a silver band, which is the tolerance band. Now if we look at the resistor color code, and what you can see, this is how the code translates. So band 1, if it's black, then the numerical value is 0. Brown is 1, red 2, orange 3, etc. And that applies to band 2 as well. So that's the same. Now band 3, as I said, is the multiplier. So if band 3 is black, there's no multiplier in there at all. If it's brown, it's multiplied by 10. If it's red, it's multiplied by 100, 1000. For orange, etc. So as you go down, and then you can see for band 4 you got gold, which gives you a tolerance of 5%. You have silver, which gives you a tolerance of 10%, or no color at all gives you a tolerance of 20%. If you write it down in the front of your books that I suggested you keep the other day, or better still in the back, and you can use it as a sort of an appendix, then if you need to figure out the value of a resistor, you've always got your table to hand. So I'm going to use this now in working out the value of this resistor, and then we're going to see how accurate it is, and then we're going to have a look at applying Ohm's law to this circuit. Okay, so if we look at this resistor, then we can see the first band is red. We can see the second band is red. The third band is black, and the fourth is silver. Okay, so if we look at our table of our color code, we can see that red is 2 for band 1. Similarly for band 2, red is 2, and then it's black. So the multiplier is nothing. We don't multiply it by anything. We won't say 0, because 0 would insinuate it's multiplied by 10. It's not. Black is nothing. So what that is telling me, the resistor value is 22 ohms, and silver is telling me that it's within 10% tolerance. So it's got to be plus or minus 10% of that value. So first of all, let's have a look to see what the actual value of this resistor is with ink. So we'll have a look at the tolerance value and everything in it. So if we look at the value of this resistor, it's going to say, I'm going to give the wires a little scratch just to make sure there's no oxide on there. And we can see we got about 23.8 there. So we make a note of that. So we measured 23.8 ohms. Now it's got a silver tolerance So that means it's going to be within 10%. So if we look to see if the tolerance of this resistor is right, then it could be plus or minus 10% of 22 ohms. So let's have a look what 10% of 22 ohms is first of all. So to work out the percentage, because it's percentage means per 100, so we can say 22 divided by 100 and then multiply by 10, and that's going to equal 2.2. 2.2. So what that means is the resistor value, the measured value, can be 22 plus or minus 2.2. So if we say 22 plus 2.2 is going to equal, and this will then give us the range. That gives me 24.2, and 22 minus 2.2 that equals 19.8. So what we mean by the range is, with a resistor of 10% tolerance at 22 ohms, it can be anywhere in the range of 19.8 ohms to 24.2. We measured the resistance at 23.8 ohms. So what that means is that is right within that range, and that's correct. So we'll make a note now of our resistor. So we know our resistor for this circuit is 23.8 ohms. So let's have a look at this circuit then. So now we're going to measure the voltage of the battery. We know it's going to be approximately 9 volts. So let's test it. And that's got 9.02 volts. So we know our voltage for the circuit is going to equal 9.02 volts. And then we're going to reconfigure the meter in a second. But first of all, let's get this voltage into the circuit. There's a voltage. We're going to reconfigure the meter now to read current for amps. And now if we put the multimeter into the circuit, we should see the current will run, and that's giving me about 0.33 of an amp. So we can say the current A is 0.33 amps. Okay, so what we can do now, if we shift this all out of the way, if you remember, we said Ohm's law, the voltage in the circuit is equal to I times R. And if we change this A here for an I, we want to find what that is. We want to confirm what the current is in that circuit. So if we rearrange that, I is held to that R by a multiplication sign. So to get her over the other side of the equals, we do the opposite to that, which is divide. So that will give us I is equal to V divided by R. And if we pop the figures in to our little equation, I is going to equal 9.02 divided by the resistance value, which is 23.8. So we'll input those numbers into the calculator, and we'll say 9.02 divided by 23.8, and that will equal 0.33 0.37 amps. Is that correct? Well, we measured at 0.33, so that's not bad actually. That could account for some oxidization of the connections or something to that effect, errors within the device and stuff. So I would say that that is correct. Thank you very much for watching. I hope you enjoyed that, and that sums up really how we can use Ohm's law in a circuit. Please subscribe to the channel, and please write any comments you have to make in there. If I can help you in any way to do anything that you need to know, I'll certainly try. As I said before, I can't promise, but I'll do my best.